All right, thank you everybody so much for joining us here tonight for our presentation. Just a few housekeeping items before I introduce the speakers. One, thank you so much to the BSA for hosting us again. We're really glad to see that your facilities are back and up and running. And thanks also to all of our members for helping to make this event possible. And also to Mass Save for helping to make this event a reality through their support with the Passive House and All Electric Homes Training and Workforce Development Program. Mass Save is a coalition of states utilities that offers robust incentives for passive house building. There's single family incentives and also pretty robust multifamily incentives, $3,750 a unit. And if you're interested in accessing those at the earliest stage possible in your project, I urge you to reach out to multifhr at icf.com, or you can reach out to us at PHMass and we will help you reach out to them. They're really helpful and they can help get your projects off on the right start. We also have CEUs available for tonight's event, and to request them, there's a QR code at the back, but you can also just go to phmass.org/CEU, and you can just put in your name there and you'll register for this event's CEUs. One more event that I just want to flag up for everyone online and here. If you don't already know, on December 9th, we're going to be holding our annual Passive House Symposium. The theme this year is raising standards, lowering costs with the hand gesture. And it's going to be a really exciting event. Registration is now available on our website at phmass.org. I encourage you, I hope you'll see all of you there. Tonight's event, we're really excited to have two people from RDH Building Science, John Mann, who is a verifier for the Boston office, and Dave Stanton, coming here all the way from Toronto, who is probably one of the biggest air tightness experts in the East Coast, if not North America, right? So we're really excited to have both of them here to talk about going beyond the blower door, giving us a real in-depth look at how you do air tightness correctly. So give them a big round of applause to John and Dave. Get this one. Get this here. There we go.
All right. That works, right?
Yep.
Yeah. All right. Thanks a lot. Yeah, we're going to talk a little bit about blower door testing. We've done a lot of it, so we just want to share some of our experience with you. And as it relates to passive house, but also kind of just in general, as it's coming up in, I mean, Massachusetts already has it in their code, so it's a lot of fun. A little bit about RDH. We've got offices kind of all over North America, Canada, US. We're east to west coast. Where I started was actually in the Seattle office, so that's part of the reason I did a lot of air leakage testing. They've had it in their code since 2009. So it's been 16 years of air leakage testing over there already on all buildings. So it's we've got a lot of data from all of those tests and had a lot of fun working with contractors and everybody over there on doing those tests. So what we're going to go over, I'm just going to look at this quick. So we're going to go over why air tightness matters, how air tightness testing works, how to achieve air tightness in your buildings, how to plan a test and how to execute the test. And then we're going to go into our case study of Bunker Hill Building M. And then we'll just do some quick summaries and key takeaways at the end there. I have my hat on because I sliced my head the other day, so I'm going to save you all from that. So why air tightness matters? Airtight building enclosures, they can control air leakage, and as a result, that directly influences your energy consumption. So we're getting monetary gains, right? We're saving some heat loss. We're also improving our indoor air quality, reducing the amount of pollutants that are coming across our enclosure. Improve our building durability, condensation, water, mold, decay, right? If we can control air, we can control the moisture transfer across the enclosure through potential condensation. And it still also helps with bulk water infiltration as well, right? If we can stop air, feels like we should be able to stop bulk water from getting in too. And then occupant comfort, thermal acoustic, right? Makes everybody feel better in the building. The other reason we're at a passive house meeting here. So passive house requires nice tight enclosures. So, right, PHI requires 0.8, 0.6 ACH at 50. Phius gets a little more fun with, depending on if you're a combustible building or a non-combustible building, but also very, very airtight target, 0.06 CFM per square foot at 50. Again, that's not a hard rule. It depends on if you're combustible or non-combustible. We've also got Massachusetts code. So this is very similar to language to what was showing up in Seattle back in the day. You're required to hit an air leakage, maximum air leakage rate of 0.35 CFM per square foot of 75. And then there's the optional energy credit if you go for an even tighter air leakage. You gotta be careful doing that. It is an easy kind of cost saving measure up front, but it can come to bite you if you don't hit that target. So you do have to really pay attention while you're doing your air leakage if you are gonna go that route. So how air tightness testing works. Air leakage requires two things. Requires a pressure difference and a hole. We need a force to push the air through some kind of opening, right? If we have a hole, no pressure difference, we're not going to get air leakage. We have a pressure difference, no hole, again, no air leakage, we need them both. Okay, so simple enough, something's got to push the air through and we need something for the air to go through. So for air leakage testing, what do? We create a pressure by installing a fan in a door in a building, and we pressurize that building somewhere around 50 pascals, 75 pascals, depending on your target. And then we turn on that fan, get that pressure difference, and that pressure difference is going to push air through any holes that are in my building or in our building, right? And then whatever air leakage is going through my fan is the exact same as the air leakage leaving my building, right? Conservation of mass, physics, fun science stuff. So that means that we can get our air leakage rate by measuring the air flow through our fan and hitting that pressure difference. Looking at some other types of air leakage tests, right? That was a whole building air leakage test. If I stick a fan in, say, just a particular floor and I pressurize that floor, I will measure the air leakage across interior partitions and across the enclosure. This is a compartmentalization test, right? If we're doing Phius, we do have compartmentalization testing requirements for our suites. Same with Energy Star, we were just talking about that with Joe there. So this would be a compartmentalization test. Now, what if I want to get only the air leakage across my enclosure on this floor? So we need two things, right? We need a pressure difference and a hole. So what I can do is eliminate the pressure difference by putting fans in the floors above and below, right? Then I get zero pressure difference across that floor. Now I'm only measuring the air leakage through the envelope, right? But this is tricky, a lot trickier than you think. This is a really, really cool building. There's no stairs. There's no elevators. So when I start putting those in, there's all these bypasses. So guarded testing can be a very challenging test because we also have mechanical systems, right? That can bypass my test zone, and I will measure that air leakage. So we need to think about how much prep work is going to be required to stop the air leakage through bypasses. You have an option of guarding the bypass or sealing them, right? Most cases, we're going to seal them and basically do our best to avoid those bypasses. There are other challenges with guarded testing. The connectivity between the floors of the guard zone and the test zone also matters, because if you have too much connectivity, your fans start to fight. And you may end up basically pressurizing the floor below with the fans in your guard zone. So you do actually have to make that your floor and ceiling of your test zone as airtight as possible. Even though we are going to guard it, we still need to make it as airtight as possible. So yeah, it is a lot trickier than we think. And as a result, getting someone on board that is familiar with how these tests works and the nuances is going to be very important if you ever go down the guarded air leakage testing route. This is just a graph I made. It's basically just to show you the error that you can have in your building. So if someone really doesn't know what they're doing, that big blue one, I guess I should point this. Oh, you can't see. Oh, there we go. Laser pointer. This big one right here, that's showing that you could essentially measure double the air leakage of the actual enclosure if you don't know what you're doing. You can really screw this test up. So there is potential for error when doing a guarded test. It means you need someone that knows what they're doing and maybe being careful about choosing when is the right time to use it. Only use guarded testing if you have to. So how do we achieve airtightness? Well, a simple way, they were giving these stickers out at the Passive House Network Conference in 2023. This would be public prefab. They told us you could actually take these, they were stickers, and take them and just stick them on the hole if anyone punctured a hole in their membranes. So it says, imagine this house is a balloon floating above shark infested waters. If we poke it, we will die. So basically, let's just get everyone on the team to think that way and be afraid, and we're going to get a nice airtight building, right? So let's think about that through design and through construction, which would be build, and through confirm. These are, we've kind of coined these as our 3 keys to airtight building, right? I want you to remember at the end of this entire thing. So we need to remember design, build, confirm. Do all 3, okay? So when we talk about design, what we're talking about is clarity of our documents. Our drawings need to be clear. Our specs need to be clear, right? We need to be communicating all of this information to the contractors so that they know what they're getting into essentially, and so that we're on the same page. Making sure in our documents that our material selection and assemblies are also clear, right? Using good materials, using compatible materials, not mixing too many things that are possibly gonna not work together. Detailing everything in our drawings so that interfaces are buildable, right? We need to think about how the contractor is going to put this together. We can't just draw a line that's continuous. We should be thinking about, okay, what does that really mean? And then we basically do the pen test. It's just making sure that we have a continuous air barrier, right? And we'll get a little more into the pen test a little bit later. And then again, design airtightness. It has to be a continuous air barrier, right? Can't have a hole. So in clarity of documents, again, making sure that you have a clear performance target. So what is the air leakage we have to hit? And it's important to note that when we say that, it's not just about the CFM per square foot number. I need to know what pressure that's at. The CFM per square foot number means nothing to me if I don't know what the pressure is. It could be 5 pascals, could be 50, could be 75. I need to know that on my end, right? And the GC needs to know that. We all need to know that. Again, having a back and forth process, like a plan between the design team, GC trades, so that we can refine any performance targets. Are we going for passive house? Are we not? Are we just going code minimum? Are we going for that enhanced number? What does all that mean? And what are the trade-offs? And making sure the GC is on board with all of this stuff. And this is all obviously the responsibility of the design team, right? And some of the things that we usually try to include is a specific airtightness specification section that lays it out. Okay, here's what we need to do. We're going to do an airtightness test at this point. Mid-construction, a final airtightness test. Here's our target. Here's who's responsible for prepping the building, who's responsible for doing the test. And then again, obviously our deliverable is also a drawing set that does include an air barrier drawing. So it tells me where the air barrier is in everybody. And then we also, for passive house projects, we also usually provide a passive house construction verification plan. It's basically a giant spreadsheet that says, here's what we need from you as the contractor. Here are the details that we're worried about. And here's what we need you to keep an eye on and check, right? The pen test, it's pretty simple. Take your plans, take your section drawings, take a pen and draw where the air barrier is. If you ever have to lift the pen, your air barrier is no longer continuous, right? So we usually ask that these get actually a drawing actually gets included in the AO sections right up front, kind of like the fire code drawings. Same idea, just do an air barrier drawing so that everybody knows here's where the air barrier is. It's got to be continuous. And then the advantage of that is you'll see, uh-oh, maybe I'm passing, a wall that's could interrupt my air barrier. So I need to think about how I could break that wall up. And then, yeah, identifying elements of the air barrier, membranes, sealant joints, tapes, right? Any other transition. And then again, clearly communicating where it is, because it is very valuable to the tester. If we're only on the job as the tester, trying to figure out where the air barrier is with the set of drawings can often be a bit of a challenge. And then we're taking some guesses and making some assumptions on that enclosure area for our calculation. So it's very useful for us, very useful for the GC to know where that is, very useful for you, right? As a designer, for everybody. So next step, build. This includes construction sequencing, translating the details from design phase into reality, right? You're actually putting this thing together. So looking at these details and think about how you're going to do it, and then telling us if, if we're on the design team, telling us if you need basically us to make some adjustments, putting together some mock-ups, and then having a accountability or responsibility or role, right? So we usually recommend establishing this air boss role, where you've got someone on the GC's team that's going to take responsibility for the air barrier. Just looking at the construction schedule, this is what we often do when we're on projects early enough. We'll work with the GC, take a look at the schedule, make some markups with the recommendations on when we should be coming for field review to help take a look at the air barrier, when we should be doing some mock-up reviews, maybe some testing, putting all those milestones in there, doing a mid-construction test. We almost always recommend a mid-construction test is done, which is really just that test at the point where you're partway through construction, just to kind of see, are we on track for meeting our final air leakage target or not? And then a final compliance air test. So keeping all this information in the schedule, planning for it, because these things do take time, right? Prepping the building takes time. We need that accounted for in the schedule. So we want to get that all in there. So in terms of looking at the sequencing maybe a little more closely, and Joel told me that this is a really accurate construction schedule drawing over here on the left or right. My dotted lines are beginning of construction, end of construction. So I want to look at this schedule and think, okay, if I'm going to be doing, a mid-construction test, when do I want to do it? I need to do it after the air barrier membrane is installed if I want to do the whole building, right? But I want to be able to see the air barrier membrane, and so that I can see if there's any leaks in it while I'm doing that test. If it fails, I want to know if there's leaks, and I need to be able to see them. Problem with this schedule this way is I'm going to have insulation and cladding that's going to block my ability to review the air barrier while I'm doing the test. I won't be able to see where the smoke's coming out. IR throws everything off when you've got cladding and insulation in there. So it's way more challenging. With this super accurate construction schedule, I can push the insulation and cladding. If I work with the GC, maybe we can push insulation and cladding. Now I have the air barrier fully exposed. I got cladding clips installed, so I get those screws through my air barriers for the cladding clips. I can now do a test, take a look at, actually review the air barrier. We can look for room for improvement. And if this is possible, this is ideal. Now I can do a whole building. That's really what I want to be doing with mid-construction tests. The reality is, you can't always do that, right? So there are the other options, like we already talked about. We do have floor-based guarded testing, right? That will give you an air leakage number. The only thing is, as you go further to the right on these kind of options, your risk is going to increase, right? When I switch to a guarded air leakage test, I'm now testing a particular floor. I'm not getting the entire air barrier. And in the particular case that we're looking at here, that's probably the easiest floor to get airtight. It's the middle of the building. Right? So when you start looking at guarded testing, often you're gonna test more than one floor, right? We're gonna do a test on a unique floor, ground floor, probably top floor, and a typical floor. So now it's 3 tests, at least, in something like this. And then when you get to suite-based testing, that's useful for compartmentalization, right? It is good to do mid-construction test for compartmentalization testing. In terms of how well that tells me how close my enclosure is to actually achieving my target, it's not great, right? There's no correlation. They've done studies on it. There's no correlation between the compartmentalization number and how tight the enclosure is. So I don't actually get a lot of great info. What happens when I get down to the suite-based part is I usually say, okay, you know what? We're gonna smoke. We're gonna do a lot of testing. We'll pick some suites and we're gonna smoke the enclosure. And the goal is no smoke, right? That gives me at least some confidence. We do a lot more testing, and it's not gonna give you a quantitative number, but it'll give you a qualitative number. And right now, I'm just talking about mid-construction tests, right? So some of the challenges in the construction side that we've kind of encountered, this is what we've already talked about. We want to be able to see the air barrier, right? You can see on that left photo, we were doing some testing. They were failing to meet the target. So we did some smoke testing with the insulation installed. All I know is there's a bunch of smoke coming out from behind it. I have no idea why. Take it off, just a couple screw holes that they didn't seal, right? But that's a lot quicker and a lot easier. It took, probably an hour to figure this out because we had to find the trade, take the clad to take everything off. If that wasn't there, it's like 2 minutes, right? Another thing that we've kind of run into is crew changes, not full trade changes. This is just a switch on a passive house building. And they did end up hitting the target eventually. Just like they managed to finally find the stud. And this was simply, the whole rest of the building was going very well. And then when we got to the top, all of a sudden they had an entire crew change. There was no real plan in place with the team on, are we going to do any training when we get a new trade on, which, looking at this, yeah, probably we should have had that. So thinking about that possibility, if you're going to have a crew change, have some kind of program in place that'll get everybody up to speed and on the same page, right? Yeah, so this was kind of interesting. Lots of screw hole misses. They installed the membrane over top of a temporary cable when you could just go right under it, right? So thinking about that challenge with the construction side. Mock-ups, we are always going to recommend mock-ups. They don't have to be standalone. Standalone is beneficial, is useful. It is an added cost, so we need to balance that. We can do obviously on the building mock-ups and test those. When we do these mock-ups, there's always something great. Something is always discovered, a better way to do the install. Doing the testing, learning that, maybe some of these sealant joints aren't getting installed properly. And we just need to work on that or pull in, someone else to do those sealant installs. This is actually the bottom mock-up. These bottom photos here. This is a mock-up for a passive house building. The fun story on this is we were supposed to include a section of curtain wall. And we asked for a sample so that we could get that installed. We got just the corner. So we did not test this mock-up, even though we really wanted to. And then obviously, so the top, this photo here is, that's an in-place window test, right? We did an air leakage test on an in-place window. So again, just as long as we're doing mock-ups. And then the air boss roll. We find this very, very useful and important, and it does tend to lead to much better installs. Ultimately, when you have someone that is going to take that responsibility. The air boss's role, and this is kind of one of their more important roles, in my opinion, is really to foster that team atmosphere, right? We need them to be a positive kind of force to get everybody rallied together behind this goal of achieving our airtight building, right? And so we need a no blame culture. They need to help enforce that no blame culture. If there's a hole in the air barrier, I don't care how it got there, let's fix it, right? Just tell me. I don't care. I'm not gonna get mad at you, right? So, and they're gonna be the person that's gonna coordinate with, you know, your test agencies and getting the whole building prepared for your tests. So next step, right? Confirm. This is your third-party reviews, your contractor, air boss walking around, doing their QA, QC checks, maybe having a checklist, maybe the trades have their own checklist, whatever you want to do. You need those kind of confirming those visual checks to make sure that everything's getting installed properly. Qualitative testing, water testing, smoke testing, infrared if you've got an IR camera and you got the right temperatures. Quantitative testing, right? Measuring the air leakage, doing that mid-construction test. Maybe you're gonna do quantitative tests on the window. All depends on how you wanna go. And then making sure you've got that risk management approach, right? So that is planning for those tests, knowing what you're gonna do to make sure that you're gonna stay on track. There we go. So yeah, again, we're back to mock-up testing. We already kind of talked about this. We are doing a lot of kind of air and water testing on these mock-ups and trying to do that at that point where we can make repairs. And then these are some of the air leakage detection things. We do IR if we can, we do smoke as well. The nice thing about IR is you can kind of look at the whole building and you do a depressurization test. You run and you scan the building with an IR camera, and then you do a pressurization test. You run and scan the building with an IR camera, and if it's hot in the building, it's cold outside, the hot spots that show up in the pressurization test are going to be air leaks. So we've kind of pointed out a couple. There's other ones in this photo too. And then a lot of times we do confirm that with smoke testing, or we'll do smoke testing as an alternative just because we don't have the temperatures, right? So all three must be present, or we design and build but confirm too late. This was actually a building that was going for high performance targets. And you can see it was pretty air leaky. Or you build and confirm, but don't really design because the design is, well, it's just spray foam everything. So it could be the contractor even made that call, you never know. Design, and then you don't build or confirm, right? They clearly designed an air barrier. We've got Tyvek, but there's no tape, there's no staples. Things are just kind of blowing all over the place. This is nothing. We didn't design, build, or confirm, and we ended up with moisture on our sheathing and rot. So, all right, test planning and execution, you're on it.
My turn to talk. So now we know about designing, building, confirming. Well, to do your confirming, you have to plan your test and run your test. So first step to all of it, determining your airtightness requirement. What do the specs call for? What does the code call for? What is the governing body and what are the requirements? Talking passive house with Phius, 0.06 CFM per square foot at 50 pascals. We've determined that. Now we need to go through, let's look at our drawings, perform our takeoffs. What is our enclosure area? Do we have a continuous air barrier? Have we passed the pen test? Is there a separate drawing that shows this air barrier that we can reference as a quick guide? Once we've confirmed these drawings, have our takeoffs, we're ready to move to the next step. And we would be preparing our testing plan and building preparation requirements. The test plan will just outline how are we performing the test? What equipment is going to be used? Where are we going to put the equipment? Building prep requirements, what needs to be temporarily sealed, what needs to be shut, what needs to be powered off, all of those sorts of things. Once we have our plan, we've distributed it to the whole team for review. We'll sit down, we'll have a meeting with the project team, contractor, architect, testing organization, whoever may be involved. During this meeting gives us the opportunity to review the plan with the full team, answer any questions people may have about the said plan. Make sure that everyone understands what the air test actually entails and what we're going to be doing. now everyone's aware of what needs to happen. So we start preparing the building about a week before the test. This is where we're going to be putting in our temporary seals for a mid-construction test, or making sure everything's set to the proper setting, HVAC systems powered down, windows shut, that sort of thing. As the building's being prepared, you want to make sure you get out there as the testing agency. We want to do that pre-test site visit. Let's make sure that all of our preparation has been done as needed. Maybe something came up, we can't actually prepare as planned. Well, we pivot, we talk, we have this site visit to figure out what we need to do next. And then we also use this site visit, we look at weather conditions. You can't air test in poor weather conditions, which we'll touch upon more later. Now, we've prepared the building, we reviewed the preparations, it's time to test the building. Let's turn on our fans, get our test result, and issue our report with the results that everyone's been sitting and waiting patiently for. So to dive in a little bit more detailed on what this test plan and building preparation requirements look like. For the whole building air tightness test, we're looking at what the air barrier extents are. What is excluded from the air barrier? What is included? A common thing that we see in passive houses is the trash room will be excluded. So make sure that that air barrier is continuous around it. Maybe they chose to include it on the project. Kind of just understanding, working with the project team, know where that air barrier ends and begins. Another part, zones that are connected. You want to make sure during your test that everything can be connected. Maybe you have a penthouse on the roof and there's no access to it. How are you going to pressurize that penthouse to make sure that you have equal pressure throughout the whole building? Maybe you have to set up a fan up in that penthouse. Maybe there's a stair shaft or an elevator shaft that leads to what you need. Understanding how you can keep the building open and test it as one full interconnected zone. And then also using this opportunity to calculate your enclosure area. What is the surface area? Roof, walls, slab. All of that added up is our enclosure area. And we already know the max flow rate of our fans. Well, now we need to find out how many fans we need and where we need to put those fans on plan. Sometimes there's doors that are too small for the fans. Other times doors are too large. For doors that are too large, frame them down to a smaller size. For doors that are too small, move on to the next one.
So one other thing to point out with these test plans is we usually identify whose responsibility it is, right? So most commonly, when we're doing a test, the GC is doing the prep work for us. We don't tend to do it ourselves, which is part of the reason we do that pre-test site visit. We're going to see if they prepped the building properly or done the prep that we've kind of asked for.
Yes, exactly. And so looking here at a mid-construction test, well, on our test plan, where are we at in the construction schedule? What windows are going to be installed or not? What doors are going to be installed or not? What mechanical systems may or may not yet be installed? And then also looking at our mechanical drawings as part of this, making sure we understand where all of those ducts are leading. Do you have louvers that are just going out? Make sure those are taped over. Plumbing traps. You don't want sewer smells in your building during an air test.
You will know.
You'll know immediately. It is not pleasant. And then, of course, Phius offers the ability to seal non-threatening leakage areas, trash chutes, ERV dampers, door thresholds, panic hardware, that sort of thing. Identifying all of these on the plans to save yourself time when you're doing that pre-test preparation walk. Also, as part of the test plan, we usually issue a checklist. This is where the contractor who's doing the prep work can take that checklist, distribute it amongst their team, and instead of walking around with all pages of the test plan, they can have a couple pages of a checklist. Okay, I'm in charge of level 2. Let's make sure all of the exterior doors and windows are shut, all of our interior doors are open, and all of our plumbing traps are primed on level 2. Check. Move on. Another big thing here is the fire alarm and test mode. During these mid-construction tests, you're going to have construction dust everywhere. If your fire alarms are active and on, you could be blowing dust into these alarms, even for final. And the last thing you want to do is set off a fire alarm while you're testing, especially when it comes down to running smoke and doing your diagnostics.
We have had the fire department get called.
And I have set off fire alarms on my side. It's not a pleasant experience. So we now have our test plan. We've met with the team. Everyone knows what needs to be done. Now it's time to start preparing the building. Step one of the preparation, looking at mid-construction testing, we have doors that are not fully installed, windows that may not be in place, door thresholds that are not put in. And this is understanding why is it still open and understanding what materials can be used to temporarily seal it off. If you have an opening that's 10 by 10, well, maybe a sheet of plastic isn't going to be enough to seal that off. We're inducing a pressure on this building. That plastic, that 10 by 10 opening is going to feel the full force of that pressure difference, which is going to exceed 100 pounds in most cases. So think of it, would you trust that plastic to hold you if you were standing on it? If the answer is no, you should probably seal it up using a piece of plywood. So for large window openings, door openings, cut plywood, use some 2x, frame out the door, and use tape around the seams. At the door thresholds, tape them, use plastic. Understanding how large the opening is and what materials can withstand the forces that the fans are going to put on them. Other preparation things, going to the non-threatening leakage we touched upon earlier. Trash chutes. Your trash chutes are going to be open to allow for proper ventilation of any trash gases, making sure those aren't being expelled within your building. Your ERVs. Most of the time, your ERVs are going to have operable dampers that you can shut. Well, maybe you can't shut those dampers fully, or you are having other issues. Solve that problem, put some plastic over top, tape the seams, and everything's temporarily sealed up for your test. So now that we've started preparations, we want to come to site and do that pre-test site walk and start setting up for our test day. So some of the biggest things to focus on when you first end up on site on test day, or even before you get on site, what are the weather conditions? Is it windy? Is it raining? What are the temperatures? Get on site, measure the wind speed. Check those temperatures. Stack effect can be a big issue for some of these taller and larger buildings that we may be testing. And then once we've confirmed weather conditions are great, well, now it's time to start testing and understanding how long this test can take and why it's really crucial to incorporate this into your construction schedule, especially when it comes to mid-construction testing. Setting up all of your equipment, unloading, doing your pre-walk checks can take upwards of an hour. Now you have to start setting up your fans, your manometers, tubing, internet connections, Ethernet cables, whatever it may be, another hour, hour and a half. Now you're ready to turn on the fans, run your test. Pressurization, depressurization, one, both, depends on the test that you're going after. That 2 to 4 hours, also dependent on the weather. And now say you're failing your test, you want to do investigation. That can take upwards of another 2 to 4 hours, running around the building with your IR camera, with your fog machine, making sure someone's outside in the same area. And then you're finally done with testing, finally done with your diagnostics. Well, tearing down your equipment is going to take just as long as setting it up. So understanding that a test for smaller buildings may take 4 hours, for larger buildings could take up to 12 hours. Now you're running the test. Is there a delay? There you go. Running the test, set up your software. You have to take your baseline. The baseline on the software you use is 2 minutes. You have to wait the 2 minutes for all of that to run. You're adjusting your pressures depending on the standard you're following. You may have to take a certain amount of measurements for your multi-point test. And then you're checking your results, making sure everything's in conformance. What are my air leakage rates? What's my line of best fit? Do I have an acceptable slope, acceptable correlation? Understanding all of the points are similar and following that same line. So environmental conditions to consider with wind. First one we look at low wind speed, ideal for a test day. you'll see a very clear stepped graph, and your test points are going to be clearly labeled, clearly marked. You're going to get a very accurate and quick test result. Now, if it's a little bit windy, moderate wind, instead of running a 20, 30-second measurement, you may be running a minute-long measurement to try to get the results you need, adding more time to your test. And then in extreme cases, significant wind, large wind gusts, don't even test on these days. You're never going to get results. The wind's going to interfere too much, and it's not worth wasting your time trying to get things to work. So I'm going to talk a little bit about the Bunker Hill Housing Redevelopment Project, Building M, which was fully Pass House certified as of May of this year. And it is fully occupied now. Residents are living within. Background of the project, it's in Charlestown, owner LMP, partnered with the Boston Housing Authority and the Charlestown Resident Alliance, designed by Stantec and constructed by Suffolk, where RDH came into play. We were the verifier, enclosure consultant, assisted with moisture management on the timber, and did construction field review and testing. Key elements focused on the project: mass timber, passive house, and affordable housing. And we're going to touch more on the mid-construction test and what we had to do here. Going into our design, build, confirm that we talked about earlier, we had our design. This here is the example of what we do with our windows. We have our continuous air barrier with our windows sitting in our panels. Well, now we go to the factory, we see how these panels are being constructed, making sure everything's set, continuous air barrier, and now the panels are installed on site, making sure all those final primary seals are installed around your window perimeter, making sure there's no discontinuity, no holes, no breakage, making sure everything's matching what was designed. And next part, this building being a panelized system, we had horizontal joints. Same concept, making sure that you have your continuous air barrier going through, all right? Panels designed, let's set it on site, make sure it's constructed. We have these gaskets during construction, and now those gaskets in place, we're installing our primary seal, confirming that on site. Similar thing with the vertical joints of the panels, very similar to the horizontal, just making sure that everything remains continuous going through. And going into the whole design side, we're looking at the spec, all right? How was the spec written? What are our requirements? 0.06 for passive house. We're ready to move forward. We're reviewing the panels in the factory, and we're seeing how everything's coming together on site. This here overall, as the building's being constructed, the panels installed, and since this project was panelized construction, a little different than your typical mid-construction test may be done at about mid-construction. This one being a panelized system, air barrier fully installed, your mid-construction test is going to be performed closer towards the end of construction. And then you're doing your pre-walks before final testing. All right, they're doing some final last-minute detail work, and now we're ready to do our final test. So moving forward more, just kind of the overall process. Early on in design, we were able to do PMU testing, making sure that what we designed was working properly by running some mock-up tests. Now we're going out to the factory, making sure the panels are being built, and now we're doing our field inspection. So the constant field inspection the whole way through, from mock-ups to factory to site. Now here are just some images of our mid-construction testing. We have our blower door set up in a temporary wall because that wall was not yet in place. We didn't have a door there. We had to frame out a wall on the day of testing to set our fans up in. Then you see on the right side, we had to put plywood up in doors that weren't yet installed. Similar thing here. One part of the building had curtain wall that was not yet installed because that's where they were doing all of their construction loading. So we had to treat an interior partition as our exterior air barrier for this mid-construction testing, making sure that all of our seams were taped, housed, and had temporary doors built and also fully taped. And then here, more examples of how we sealed off around the window access points and a rooftop doorway. Plywood, taped seams, making sure that we're getting very minimal leakage through those temporary conditions. And so running the whole building mid-construction test, we're coming out at around 0.068 CFM per square foot. So I know I talked about, we were targeting that 0.06, we're at mid-construction, okay, we're just above. What were our temporary conditions? Why are we not there? What's our comfort level about getting there to the next step? So we go forward and now we're performing our final testing. We have final conditions. All of our windows are installed. All of our doors are installed. We only needed 2 fans that we learned from mid-construction. Now we're at final. We didn't have to worry about adding on a 3rd fan in case things were performing worse than expected. So we set up our 2 fan. We ran our IR scan with the testing, no major visible air leakage. And we come out to 0.055 below our Phius target, as expected, as designed. Everyone was happy. We moved forward, submit for certification, and we passed. Just to wrap things up, I know we want to leave some time for questions, but overall key takeaways from here. Thinking about our design, we want the documents to be clear. Where is your air barrier? How is your air barrier drawn? Making sure everything's continuous. Did you pass your pen test? Now, your building, making sure that the construction schedule is sequenced properly, making sure that you're not blaming other people. If someone is walking by with a ladder, you puncture the air barrier, it doesn't matter that it happened. All that matters is that it gets fixed. And then, of course, that goes to coordinate with the air boss, making sure someone from the contracting team is there to perform checks and make sure that whoever else is there doesn't, the architect, your consultants don't have to be there all the time, working side by side with that air boss. And then you're confirming, you're inspecting, you're testing, you're inspecting, and then you're testing again. You can never have too many inspections, and the only way to know if you're going to pass is by testing and inspecting, just to drill that in your head. So thank you all for being here, listening. We'll open up the floor to questions.
Let's see, we got another mic here, it's working. I know we've got questions online, but we're gonna go with Lauren Fallon first.
Hi, a quick question for you in terms of how you make sure the general contractor is appropriately planned for the cost associated with your testing protocol. So it seems like a lot of that sort of prep work is figured out once you're in construction, you know, what you'll need to block off and what needs to be taped and sealed and how much time you might need to be on site. So how do you make sure that there isn't pushback from the GCs around like, well, we didn't really price for this extensive amount of testing?
Yeah, that's a fun one, because it's, oh yeah, right. It's a fun question. So, I mean, with the spec, we do try to write in there, you know, whether or not we're gonna go for a mid-construction test. The mid-construction test often ends up being a discussion later on. So, yeah, pricing that's a bit tricky. We try to meet with the GC during the bidding phase so we can work through that at that time. If we can. If we can't, then, I mean, it's in there and we're hoping that they're pricing it properly. For final, it is really just kind of speccing. GC is responsible for prep work. And we kind of list out, here's what we're expecting for prep work, right? We're expecting you to seal off HVAC openings, et cetera, right? We just list that out. And then it's in the spec, so it should be getting priced, right? The mid-construction test is a risk management kind of choice. So when we do put that in the spec, we are kind of saying that we do want you to do that. We think it's good for you to do it as part of your risk management approach. If it doesn't end up in there, we do generally kind of recommend a GC price it anyway, under the assumption that they would want to do it, because it is just really, it's not going to be what gets you your compliance with your final. It's just being used to make sure you're on track for it. So it's a risk management test. So there is a bit of back and forth on that one. I don't know if that helps or is a question.
All right, I've got some questions from the chat as well, if you want those.
Yeah, this question is from Kristen. Who usually provides the airtightness spec, designer or the past house consultant, or they collaborate on the spec? And then she further clarified, the airtightness spec that you guys had listed under the design tasks.
in that case, so it depends on our role on the project. We've been. If we're brought in early enough, we can provide it if that's kind of something that the design team wants. Or we've worked just with architects just to kind of create their own. So it all depends. It's a variable on who's actually going to provide that spec section. We're obviously happy to provide it. We've done it lots of times, so it all depends.
Other questions from the audience here before we go back to the chat? Not seeing any hands, we'll go back to the chat.
Great.
Excuse me? May I speak?
Go ahead, Reza.
Sorry, I didn't. I've got a question from Kurt Lamar. In your experience, how useful is the midpoint blower door test in multifamily construction? Does it occur at midpoint of the work due to delays? And if numerous doors, windows, openings, I think that you kind of answered part of this as you were going through that. I think you asked, but I don't know if you wanted to add any other color to your answer.
Yeah, so the idea behind that midpoint test, it's not necessarily at the midpoint of your construction schedule. So say your construction schedule is 12 months, midpoint doesn't mean you're testing at 6 months. Midpoint is just kind of another way of saying a during construction test. So you want to plan it and coordinate it where your air barrier is 100% complete. But then also, like David was showing in the very simplified schedule, you want to make sure that any of your cladding attachment clips are also installed, because those are going to be your penetrations through the air barrier. And that's kind of what you're looking at testing. You saw in the one image, there was the cladding attachment. They missed the stud however many times. And if that was covered up with insulation and cladding, who knows how long it would have taken to find that that was the issue. So the idea is to make sure that you're getting that test before your installation and before your cladding, and understanding that yes, there are going to be some windows and doors that aren't yet installed. And that goes back to the coordinating with the contractor and how is this going to be budgeted? How do we know that there's going to be, how much cost is there going to be incurred for this preparation work based on how many doors or windows that may or may not be installed at the time.
Yeah, and that comes back to that risk management thing, right? The more that I don't have installed, the less I can say that air test number is really representing what the final building is going to be, right? So ideally, if you can have everything installed, if you can get your windows installed, your doors installed, and all of that stuff installed, get it done and keep that air barrier exposed. If you can't, yeah, we'll work with you. We'll just note that, you know, these remain risks, right? If I block off a window, if I've got a window opening, I've got, you know, maybe an operable window. Operable windows are going to leak more than my plywood. So now if I block that off, if I do a really good job prepping that window, right, blocking it off, now that could basically end up meaning that I'm getting a tighter number for my mid-construction test than I really am going to have in the final, because I'm not measuring the leakage of that gasket as that window gets pushed open. So it's a risk management thing. You do want to get it in there though, so.
Anyone else in the room want to raise a hand? Oh, yeah.
Excuse me, may I ask a question?
If you ask it in the chat, actually, we can relay it. Sorry, just because of audio issues. Thank you.
So the role of the air boss and specifications, you could argue that maybe an air boss is means a little bit means and methods. We tend to stay away from that in our specs, but is there something that alludes to the idea that they should have one within the spec typically, or do you just have to be part of a conversation down the line?
We do put it in the spec.
You do put it in?
Yeah, we do include in the spec that there should be someone overseeing the air barrier install. We have we also include recommendations for certifications that person should have. Again, doesn't always happen, right? We do put it in the spec though, that there should be someone on the team that's going to take that role.
Cross that one in a little bit.
A little bit, yeah.
Was I also talking about the air boss too, just speaking of a Phius Pascal's project, there's certain requirements that the builder has to have. Maybe they have to be a certified builder. I know speaking for the Energy Star Indoor Air Plus, they have to be partners with those programs as well. So ideally, your contractor has someone with those certifications who's maintaining those partnerships, who's already familiar with the requirements. And so there's a pretty easy overlap, and they're not having to go out and bring on extra people to fulfill that role.
Yeah, because your question would apply to mid-construction test too. That's a little bit means and methods, right? They don't really have to do it. There's nothing telling them other than the spec that they have to, but it's a risk management thing. And we usually put it in the spec because we want them to price it. So we're kind of maybe crossing that line a little bit, but.
So here's a question from the chat. You mentioned Bunker Hill's midpoint test was higher than the target. What were your recommendations or directives to the team after midpoint? Or how involved were further troubleshooting diagnostics? How involved maybe were you? Or were you comfortable with the margin over the limit, given the amount of temporary sealing that the GC could just stay the course until the final test?
Yeah, so I was on site during all that testing. And so one of the things to touch upon during that mid-construction testing is that the weather conditions were not ideal for testing that day. So, we were talking about earlier, you want to make sure you have a nice calm day when you're running that test. Well, that day it wasn't as calm as we would have liked. So we had to take more data points, or the data points weren't as accurate or so as you would expect for that final test. And the testing had been going on for several hours at this point, longer than expected, running our diagnostics, that it came to the point where we decided that what temporary sealing has been done in the areas that were not yet permanent. So think, for example, the one area that was completely open, it was interior partitions. There was an interior floor above us, and there's supposed to be a curtain wall system installed. So we are pretty confident saying a curtain wall system is going to hold up better than these interior partitions. So we're going to get significant leakage reduction from there. Also, where our fan was set up, that was a temporary framed wall that was not fully installed with a complete air barrier. So taking those things into consideration as part of our diagnostic process, in addition to the weather conditions, we were comfortable enough that the margin of error was significant enough that we were there when we were coming to the end. And then also one thing to touch upon too, Dave was running some calculations on that number earlier today in the office, and Phius has two testing limits, one at 50 pascals, one at 75 pascals. Doing some quick assumption math, running the calculations, that mid-construction test most likely would have been considered passing for final if we were testing at 75 pascals based on the numbers that we were getting at 50 pascals. So another thing to kind of consider and think about, if you weren't hitting at 50, are you hitting at 75?
Great. When a mid-construction blower door test and even a final blower door test has failed, are there air sealing mistakes that you see more commonly to cause the test failure?
There's lots. Some of them do boil down to prep work, right? So it is, a lot of times we do end up chasing seals that have blown off, or we end up, so if you're doing a passive house, say, and you're just relying on the dampers on the ERV, dampers leak. So, you may just end up having to seal that up. The most common failure points that we've kind of run into are penetrations. And then the other one is a parapet transition is common. Base of wall is common. I'm sure many people probably could guess a lot of the spots. The other one that's very common is insulated metal panels. They tend to leak quite a bit more than you might think. It is a tricky kind of install to deal with insulated metal panel installs if you're going to rely on that as your air barrier. I was showing some smoke videos of that earlier. Soffits are a common one. We've seen a lot of situations where the air barrier membrane will stop and then doesn't go all the way to the slab above. So that joint gets missed a lot. What else? What do you think of?
Everything. The biggest one that I've seen has been, for, if you're panelized, you have to pay attention to those joints, the panel to panel joints, the slab to panel joints, the roof to panel, whatever it is. Any transition, any penetration. Another big one too would be your fire department connections, your standpipes, your hose bibs. Those are big ones. If there's exterior outlets, sometimes the plumbers, the electricians, they'll come in after your air barrier is installed. They punch through. They're not thinking about the continuity of your air barrier. No one goes back to check it. And now you have leaks through your plumbing and electrical penetrations.
It's where that air boss comes in.
Yes.
Don't poke holes in the air barrier. But someone needs to explain the stamp. That's common. The fire department connections.
Mhm.
I don't know why they get missed a lot.
We've now hit 7. There's still some questions in the chat. I think we're putting your guys' emails in the chat so we can follow up with you. I'd like everyone to give our speakers a round of applause again. Thank you so much for joining us.